Good morning, everyone. Please let me share the presentation materials. Okay, so my talk today is paddy field mapping and productivity prediction based on satellite image analysis. This is a result of a literature review in related to the topic. So as introduction, food is one of the basic needs. We can call it primary needs of human life. And to fulfill the food needs of the entire population, the Indonesian government has taken many initiatives to print new rice field in several areas. However, the problem is that the vast area that must be mapped means the mapping of paddy fields cannot be effectively carried out using manual technique. And predicting rice production as a basis for monitoring domestic production based on existing rice field data is quite important to be handled in an automatic way. So based on recommendation from many government agency, for instance, the National Institute of Aeronautics and Space, or LAPAN, in 2015, it's very worthwhile to utilize remote sensing technology with various type of sensors to map existing paddy fields as well as new paddy field. Satellite image analysis for land cover classification and land use classification is a general applications of the satellite image analysis and has played an important role in Earth observation technology. Satellite imagery is very effective for larger area with no requirements for permitting mobilization or demobilization and avoid any security issues. Deep learning is a subset of machine learning algorithm, which basically neural network based models, okay, to predict mapping from input to output, okay. And in satellite image analysis in the past decade, it shows that deep learning is very potentials, yeah, to solve many computational tasks using image from satellite image as an input, okay. Given we have high performance computing to compute the data. So the objective of this study is basically to collect and to analyze in a structured way many prominent literatures related to the topics. Okay. So basically the dataset for satellite image classification and prediction captured by various satellite devices. And in general, satellite image resolution consists of high resolution satellite imagery, medium resolution satellite imagery, and low resolution satellite imagery. Okay, and then in general, the mechanic elements of the remote sensing technology comprises of several parts, including sensors, okay, and then transmission, reception, and processing. Then interaction among those elements can be seen in these pictures. Yeah? So let's say A is an energy source of illumination, and then radiation and atmosphere and interactions with the target is become or captures by the satellite sensors, okay, using the many process, and finally we can get the satellite image. Okay, so some literature related to semantic segmentation using satellite imagery can be summarized in the following tables. So from application perspective, many prominent research use satellite image for paddy field mapping. Yeah, as you might seen from the slide, they have various satellite imagery. For instance, image from Landsat, MODIS, yeah, Sentinel-2, and interestingly, many prominent research use we call that spectral indices, like and DVI, EVI, and many more. All right, so as I said before, applications of the remote sensing analysis in semantic segmentation comprises of paddy field mapping, forest type classification or forest classification, and from semantic segmentation model perspective, several machine learning or deep learning model have been explored, like random forest, convolutional neural network, support vector machine. Yeah, but also there is some research that using rule-based model. In addition, semantic segmentation can also be used for land suitability assessment and agriculture production sustainability, detection of corn and wheat species, and crop classification using many satellite imagery, like the image captured by Landsat, hyperspectral image, Sentinel-2 Landsat, and many more. And as you might see here, several machine learning models have been explored, including decision tree, k nearest neighbor, support vector machine, and random forest. Okay. And another application of semantic segmentation using satellite imagery is for identification of rice field or mapping paddy rice field, and also rice productivity prediction. And more satellite imagery has been used in various types. Okay, similarly, that there are many machine learning or statistical based model for semantic segmentation have been explored with various performance. Okay, now from our study, the frequently used satellite imagery analysis is Sentinel and Landsat. Okay, and those image from both Sentinel and Landsat currently can be acquired or can be accessed through Earth Explorer USGS Gov website. And the prominent research for semantic segmentation in agriculture field, let's say paddy field mapping, is use spectral indices. Yeah, for instance, vegetation index, and then other index, let's say VIs, EVI, LSVI, and so on. Okay. Now, as a conclusion, a vast number of publication in semantic segmentation using satellite imagery show a huge interest of researchers around the world for analyzing satellite imagery as input for image classification, and it becomes an interesting research topic in geospatial artificial intelligence with wide potential application. For example, in agriculture field, classification and prediction technique from satellite imagery to generate land cover and land use map, and also to predict crop harvest yield. And then as a future work of this study is to collecting latest publication focusing on image classification technique that was designed to increase accuracy, okay, for especially for developing computer aided classification and prediction from satellite image for variety application domain. So that's all. Thank you.